my name is Ethan, and today I'm going to be demonstrating my Bluetooth garage door opener using Arduino and Android. So first I'm going to do a demonstration of the actual operation of the circuit. Then I'm going to go into more detail about the circuit design, the code, and the actual app configuration I made to operate it. Alright, so first thing you're going to want to do is open the app that you made using MIT App Inventor 2 and connect receiver. And once it's connected, you can hit open and close to operate the door. So as you've seen, hitting it once will open or close it depending on its original state. Hitting it a second time will change the direction of motion, and hitting it a third time will just pause it where it is. Now, as for range, you need to be within 20 feet to actually connect to the receiver. However, if you are already connected, you can go up to 40 feet away and still actuate the door. This circuit uses an HC-05 Bluetooth module, a 5 volt to 3.3 volt logic level converter, and it's powered using an Arduino UNO. This terminal block connects to a relay, which is what's actually triggering the door's motion. And on the actual design of the shield, here we have the receive pin of the HC-05, which connects through the logic level converter to the transceive of the Arduino. This ensures that we don't damage this component by transmitting a voltage that's too high, because it can only receive a 3.3 volt but can transmit a 5 volt from the Arduino. Next, the transceive pin connects directly to the receive pin of the Arduino, and it gets ground and a 5 volt power source. That same 5 volt power source goes to the common terminal of the relay. The ground goes to this side of the relay, and this is the signal pin for the relay, which correspond to the terminal blocks, which powers the door opener. This entire design is soldered to a proto board shield, which connects directly back onto the Arduino. It fits nicely in this little plastic container I got from the dollar store, so that it has a bit of weatherproof, but also makes it look a bit more nice on the wall and is a bit more quickly accessible. The circuit is powered using a simple cell phone charger plugged into the wall and a 12-foot extension cable for USB, so that I can still use the USB Type B cable that came with my Arduino board. So as you can see, the cable runs all the way along the roof, meets up here, and plugs into the wall here. So that, as mentioned, just uses the existing USB Type B, plugs in, and we can confirm we have power because the Bluetooth module is blinking. So to give you an idea of how the circuit's connected, I've taken off the main control panel off of the wall, and this is the positive and negative terminal from the actual voltage source. This is connected to the actual garage door opener motor, and the red connects to the common of the relay, and the white, which is the ground, connects to the normally open contact. So that way when I send a short signal, it shorts the contacts, and all this mechanism needs is a short pulse to actuate the door controls. So these are 9 volts, but since we're using a relay, we don't run the risk of damaging our board at all, because we're only using it through the relay, which can take up to a 250 volt 10 amp signal. Alright, so a bit hard to see with the sun, but this is about 20 feet away, and it will still connect. So it's connected, and as we carry back, and now from about 30 feet away, it still triggers the door. once again, to demonstrate how the door operates using the regular controller versus the Arduino, this button sends a short pulse to the motor. Since the door is closed, it'll open. If I press it a second time, it'll pause. And if I press it a third time, it'll start to close. Similar to how it works with the Arduino. So, opening, paused, closing. It's also worth mentioning that since this is going through the original manufacturer controller for the garage door opener, I can still use the included safety sensors, which don't allow the door to close if something is in the path of the door. So to demonstrate that, so if I have the door open and I close it, put my foot in the path of the door, it reopens. Alright, so now I'm going to be talking a bit about how I made the app, the code, and the circuit schematic for the project. First, we're going to be using MIT App Inventor 2, which is a web-based platform that uses Scratch language to create custom apps for Android. Unfortunately, it only works with Android because iOS doesn't allow you to install custom APK files like Android does. But you can use this app to make this web page to make pretty much any app configuration you want, using Bluetooth, Wi-Fi, different kinds of social media, and you can do whatever you want with this type of app. But for this demonstration, I'm using a single screen and a vertical arrangement with two buttons, connect door open and the disconnect button. I'm also using horizontal arrangement for the open/close control, which relies on the Bluetooth client 1. And as mentioned, all these are customizable with the colors, the logos, the pictures, so I can change that to black, or I can change it to what I had it before. So as you can see, it's very user-friendly and it's very easy to use. And then that's the design portion. The block portion is where you actually use your Scratch code. So I have when connect door open .click, so that means when it's pressed, I'm going to call Bluetooth client 1 with the address, which you can find by connecting using your Android device. It's usually a 6 hexadecimal divided by colons, and each module has its own specific ID. I have 3 different ones, so I have 3 IDs. And then once that is connected, it's going to set the text for connect door open to be connected. And then clicking button 1, which is the open close control, we're going to send a 2-byte number, which is 1234. You can change this for security later, but this is your security for the system, and I'm just using 1234 for demonstration. I will be changing it afterwards. Another part of the safety and security of it is only people with your specific version of the app can actually use your door opener. And if I click Bluetooth client 1, you can see that we have receive, send. You can do whatever you want. You can even make it a 4-byte number. You just got to make sure that your actual code for your Arduino is configured the same. And then in the control.click, so that means when I click this button, it's going to call Bluetooth client 1.disconnect and then set connect door open 1.text to connect receiver, which is by default. And it's really user-friendly to even design this portion of the code because the blocks just connect, so there's no fiddling around with errors, although there is warnings which it shows you where. But for the most part, it's very easygoing, and you can configure it however you really want. Moving on to the actual Arduino code for the software, we're going to be defining relay as 7 and creating 3 unsigned integers, A, B, and passcode. In setup, we're going to set our serial.begin to be 9600 BPM and our relay to be an output, so that way we can actually control the door. In loop, we're going to say if serial.available is greater than or equal to 2, which basically means if any condition is there, we're going to call the following. And we're going to set A to be serial read, which is going to give us half the 2-byte passcode, and then B is going to be the second half, and passcode is going to be the hex to decimal conversion. So we're going to have that back to decimal using this here. I just searched this up online, this type of conversion, but if you want to do a 4-byte, you just have to look for a 4-byte to decimal. So passcode, we make sure that this is matching our passcode defined here. And then we're going to serial print passcode, confirm correct passcode, and create a new line. At the same time, we're going to digital write the relay as high, delay for 250 milliseconds, and then low. And this is just going to be a short enough pulse that is going to trip the receiver on the garage door opener, but not too long that we're going to damage the module or confuse it using too much logic. So now if I open up the serial monitor, I'm going to connect using my phone. And when I hit open close, you can see it prints the passcode as well as confirmed correct passcode. And what you can't see, it is flashing on the LED. But that basically shows that our code is working. So here we have a very similar circuit, except we're using a nano instead of an UNO. This is because I only have the one UNO, but I have a few of these nanos. They still run the same ATmega 328P chipset, but they're different configurations. So it'll still work the exact same, no change to the code or anything. But here you can see this is the 5 volts power, which connects to this side. So this is the HC-06, gets a 5 volts and a power. The transceive pin goes directly to the receive of the Arduino, and the transceive of the Arduino goes through this logic level converter, which changes the 5 volt transceive to a 3.3 volt transceive, which goes to the receive pin of the HC-06. This is because although it's powered by 5 volts, it can only receive a 3.3 volt signal, otherwise it'll damage the components in the board. The logic level converter connects to ground on both sides, and pin 7 connects to an LED, which we're going to use to simulate our relay, so you can get the idea of what it's doing. So if we open up the app, connect, so I hit open close, short pulse, and that short pulse is just actuating the existing hardware for the garage door opener. The circuit for this is pretty simple as well. We're going to have our relay and our HC-05 connected to the 5 volts of the Arduino and the ground of the Arduino. The logic level converter also needs to be grounded on both of these pins here, so that we can shift it from a 5 volt signal down to a 3.3 volt. So the HC-05 has the TX and the RX pin. The transceive can go directly to the receive pin of the Arduino, but the transceive of the Arduino has to go through the logic level converter because it transmits a 5 volt signal, but the module can only take a 3.5 volt signal. So we send that through the logic level converter, which converts it from a 5 volts down to a 3 volts before we connect it to the receiver. If you don't have one of these available, you can just use a 1K and 2 kilo ohm resistor and make a voltage divider with that as well. I just chose this way because it made the soldering a bit nicer, and overall I think the circuit looked a bit neater. And you can also use multiple channels, so if you have a few receivers at once, you can easily use them together. The signal pin connects to port 7 of the Arduino, and the common is the power from the garage door opener receiver. The common connects to the other channel of the receiver, so that way we're only using the power that the garage door opener would actually be using already, so we're not going to supply too much that would cause it to be damaged. Alright, so that's going to be the end of the video. Thank you for watching if you stuck around to the end. This project was originally made for my ECE 5000 design course, and I hope you found this video informative and easy to follow if you do want to try this project on your own. I'd love to see people in the comments saying that they tried it. But other than that, I'm going to leave a parts list in the description with Amazon links and a bit more of a detailed description of what's going on. But again, thank you for watching, and hope you have a great day.